Morning students. So today we are going to continue our numericals. So I think last class we completed 8th, right? Somebody respond. The last question we have done last class. Somebody respond. Which was the last question we have done last class? Which question? Anybody? Okay, 8th one. Okay. So students, we can go to 9th question. So I think 8th question we have completed. Okay, we can start 9th question. What about 9th question? Is it difficult or easy? What do you feel? Need to solve? Students, 9th question. Am I need to solve this one? Okay. See, students, all of you mute your mic. Students, all of you mute your mic. So much disturbance are happening here. All of you mute your mic. Okay. So students, see anyway, see question number 9, 10, 11. So everything is the same pattern. Okay. So question number 9, 10, 11, 12, 13. Yeah, I think including 13, everything is going on same pattern. So I can solve just one or two questions. Which one I need to solve here? I see it's not possible to solve each and every question. So which one I need to solve here? From this, from 8 to 9 to, just respond. Which one need feel more difficult? 8 to 13, including 13. Which one I need to solve here? Okay, I think it's 9th one. Okay, I will solve 9th question. Okay, see most of the students are responding for 9th question. Okay, 9th is difficult. Okay, anyway, I just solve 9th question. Okay, see I am just solving 9th question. I think 8th question is completed. 8th question is completed last class. Okay, so I just respond 9th question. Okay, I have some response as 8th question. That's already completed. Okay, we can start with 9th question. So, see students, I can solve each and every question just to give you some method. Okay, just to give the method, listen very carefully how to solve this question. See, question say that a uniform meter rule balanced horizontally on a knife edge placed at 58 centimeter mark when a weight of 20 gram is suspended from one end. First question is draw the diagram of the arrangement. Draw the diagram is very simple thing. See a uniform wire. Just to mark, no need to mark each and every point. So just imagine 0 and this end normally 100 centimeter. Okay, 0 to 100 centimeter. A uniform meter rule. Then the question is that balanced horizontally on a knife edge placed at 58. So the knife see little bit right side than 50. So this expecting is a half one, 50 centimeter. So we have placed knife edge at 58 centimeter. Because balancing at 58 centimeter. Then question is that when a weight of 20 GF is suspended from one end. So to balancing it, where we need to suspend it at 20 GF. See, normally you can guess. See, just imagine. Okay, listen students. See, I am solving only for this question. All the questions regarding this one you can solve by yourself. Okay, so listen very carefully. Students, just imagine. There are no weight is placed. Just a scale only. Okay. Okay. So students, just a scale only. Nothing else, no weight is suspended. Just imagine there is no weight is suspended. Then, if the knife edge is placed here, on which side it will, on means to which side it will turn. Or see, it is, see here is downward. It means it is anti-clockwise. Clockwise. So students, just respond. If I didn't put any weight, and balancing on 58. On what direction it will rotate? So you can guess in practical point of view. Just respond. Students, I am just asking. There's no weight is placed. I am just placing 58 point. This side, you see, if you rotate like this anti-clockwise, rotate like this clockwise. I not place any weight here. On what direction it will rotate? Okay. Yeah, due to weight of the rule, that I am asking. Without any weight I am placing, without weight of the rule, which direction it will rotate? Yeah, normally you can guess, your guessing is correct. So, this side should have more weight. So, it will rotate in anti-clockwise direction. Okay, just visualize this thing. Now, okay, get back to question. So, okay, so this arrangement, okay, this arrangement, first feature is over. No, question is draw the diagram. So, one more thing is that when a weight of a uniform meter rule balanced horizontal on a knife edge placed at 58 centimeter mark, when a weight of 20 GF is suspended from one end, draw the diagram of the arrangement. Draw the diagram of the arrangement. So, one end we have placed 20 GF. Okay, see from one end 20 GF is placed. So, most probably we are expecting on this side because say it's balanced. Okay, so 20 GF is placed. Okay, anyway, we can calculate on calculation. So, we can put the weight. Okay, weight. Okay, now we can continue. Okay, the weight also you need to mark, that we can continue after the calculation. We can go to second question. Okay, see first question, weight also you need to mark weight. Second question says that what is the weight of the rule? Question is what is the weight of the rule? We didn't done this question. Okay. What is the weight of the rule? Now, question is very simple. See, we already studied that clockwise movement equal to anti-clockwise movement. We know that principle of movements. We are applying the principle of movement. So, we know that according to the principle of movement, clockwise movement equal to anti-clockwise movement. Both direction, the movement will be same. Clockwise movement equal to anti-clockwise movement. We know the principle. So, we are just applying that principle. Clockwise movement equal to anti-clockwise movement we are applying. So, what is the total movement? We know that momentum is equal to total movement. Moment of force equal to R cross F. So, we need to calculate in both clockwise and anti-clockwise and equating. By using that, we are finding missing time. That is our method. Moment of force in clockwise motion, moment of force in anti-clockwise motion, then missing time we are finding. Okay, we can start anti-clockwise movement. Okay, I am just placing I only. Okay, see, first of all, I am solving this first few questions. I am writing each and every step. Thereafter, I will reduce the number of steps. Okay, if you understand this concept easily, then I will reduce the steps. So, anti-clockwise movement. Okay, how much force is there on anti-clockwise movement? So, we are expecting a weight is there. Okay, over here. So, clockwise movement and anti-clockwise movement we need to. So, one side we are placing clockwise movement and other side we are placing anti-clockwise movement. Okay, we need equation for both. Simple thing, weight and its distance. See, you need to add these two things, just weight and distance. In one side we do not know weight, so just place as W. In one side we do not know weight, just imagine the W is placed there, no problem, you can guess in both way. So, just imagine weight is, we are unknown about this weight, so weight into distance. Okay, two things we are asking, weight into displacement, other side also same thing, weight into displacement, both side we are using. So, see, we know that torque rho is equal to F cross R, but F force, okay, F cross R, that force is equal to weight, W equal to mg. So, that force also is equal to weight, we can add like that. So, in one side, anti-clockwise side, weight into Okay, I will give 58, see it's marked in 58, 58 minus 50, just meaning this distance. Okay, this distance, and clockwise we are equating. Okay, so clockwise also, see weight is given 20. So anti-clockwise direction is there. Here we have weight. Okay, somewhere it have 20 is there. So weight into 20 is the given. Weight into, see, means this side weight into this side. See, these two sides we are equating. Okay, so this side weight into distance. Here also 20 into weight into distance means, see how much distance. Okay, so 100 minus, so this distance, it means 100 minus 58. See here not from, see higher minus larger, that is meaning only distance taken, higher distance minus larger. So see weight, see from here just to consider here weight into distance, this side also weight, how much weight is placed into distance. Okay, now we just equating, that's all, question is over. According to principle of movement, clockwise movement equal to anti-clockwise movement. So clockwise movement means, see just equating these two, equating means W into 58 minus 20. Okay, I am not writing one more step. 58 minus 20 means 8 equal to 20 into 100 minus 58, 42. Okay, 40. Okay, just rearranging, W equal to 20 into 42 divided by 8. Okay, simple cancellation, you can even cancel with 2 or 4. Okay, wait. Okay, so you can cut it. So if you cut with 4, 2 times, five times, again 2, so 21. Okay, so I think it's 21 into 5, so 105. So unit given same as given the question. This placed 20 gram, 20 GF is placed. Okay, so gram force. Okay, see this side is 20 GF is placed, so just to give some mass or like that, 20 GF, 20 GF, not 2 GF, 20 GF. Okay, so students, just to go through the question. Just you take that, okay, just to go through the question. See, it balancing on 58. Okay, it's balancing on 58. So without weight, it should be balanced on 50. We are balancing on 58. Without weight, we are balancing on, it should be balanced on 50. Just imagine there are no weights are placed, then it should be balanced on 50. So the difference. See, we have taken the distance from 50, where it should be balanced. Difference from 50 to both sides. we have taken difference from that 58 to both sides. So, here to here, this is the weight into this distance, here weight into this distance. Here both sides we are weight into distance, weight into distance. That's simple thing. Okay. Okay, completed. So, in both sides we are taken like that. So, without a weight we are expecting should be balanced on 50C, a uniform weight rule balanced horizontal knife head placed at 58. It is balancing on 58. Okay, question is when a weight, what is the weight of the rule that we have calculated? So, we have calculated unknown weight. See, weight on other side. Completed? Okay, see, after solving one or two questions, you will understand this idea. Same method. Distance, see both sides, see all these kind of questions are same method you are using. Both sides, distance into weight or weight into distance, weight into distance in both sides, both are equal, just equate it. Simple method that we are going to use in each and every question. Not only here, question number 9, 10, 11, 12, 13, even 14 also we are using same concept. So, what about question number 10? Question number 10. Okay, just practice few more questions, then you will easy. Question number 10, CC, just respond. What about question number 10? Shouldn't just respond. Question number 10. How many need to solve this one? See, same method only. See, anyway, I just mention the method. The question is that, okay, I just mention the method. Okay, if you don't able to solve, then I will solve next class. See, I will just read the method. A diagram given below. You have diagram given below shows a uniform bar suspended in the middle of the one by weight of 40 gram. So, everything is given in the question. And even the diagram is given. Question is in the question including diagram is given. How can you balance the bar with a weight of 80 GF? So, where should you place that 80 GF? Where should you place that 80 GF? That is the question. So, just take clockwise movement equal to anti-clockwise movement. Take clockwise movement. Clockwise movement we don't know the weight. So, clockwise side 80 GF into that distance is D. Clockwise movement 80 GF into D. Anti-clockwise movement 40 GF into, see both are 40, 40 GF into 40 centimeter. So, anti-clockwise movement 40 into 40, clockwise 18 into the distance D or whatever may be X or something, just equate it. Okay, see, just see diagram is given that anti-clockwise side means this side. Anti-clockwise side you have two distance, say distance 40, weight also 40. Clockwise side weight is 80, distance X or whatever may be, just find X, that's all. Okay, so students, I think I think I don't need to solve that question, right? Okay. So I am going to 11th question. Okay, what about 11th question? Is it easy or difficult? What do you feel? 11th question. Question number 11. Okay, so is it easy? 11th question. What do you feel? Student, just respond. 11th question. Okay. Anyway, I just mention the method. Okay, just same method only. Same repeating it again and again. Anyway, just to mention the method. Okay, I am going to raise this question. Okay, just diagrams. Okay, anyway, I need any marks. Okay, 11th question. Okay, just to give the method. Okay, method again. Okay, anyway, I just mention the method. Just try again. Okay, for each question, I just give the method and try again. Then, if you still feel anything can't able to solve, then I will solve next class. Okay. See, if I solve all the question here means no use. You need to solve the own examination. We are not expecting any question. Don't expect any same question will ask on board exam. Same pattern you can expect, but don't expect same question they will ask on board exam. So you have to know how to solve these questions. Okay, so it's not me. It's okay. Question number 11. Figure 1.2 shows uniform meter rule placed on a fulcrum. See, fulcrum is already studied in next chapter, but they use the concept here. Based on a fulcrum at midpoint O. So, yeah, diagram is given, I think. Yeah, midpoint O, having weight 40 GF and 10 is mark on the weight, and 20 GF and mark on the weight. It's on an equilibrium. First question is both are in equilibrium. First thing is that they are asking both are in equilibrium. So, simple thing, in both the cases we need to calculate clockwise movement and anti-clockwise movement. Okay, give the method only, just to calculate clockwise movement separately, don't equate, separately calculate clockwise movement and anti-clockwise movement. So, just anti-clockwise movement, same method, anti-clockwise, how much force in displacement, weight is 40, then displacement, hope you know how to find the distance, that is 40 GF, it's placed on 40, diagram is repeated, yeah, placed on, see, hope you know how to find this distance, it is 50, see, I will show you, see, it's balanced exactly on 50, it balanced exactly on 50, okay, then see the weight is placed on 10, you can see on diagram, weight is placed on 10, so what is resistance, 40 centimeter, okay, so that's how I have find 10 into that weight, okay, wait, so weight into the distance, okay, weight is 40, on diagram is still given, weight into the distance means hope you know 50 minus 10, okay, we will get 40, okay, this much you will get anti-clockwise movement, okay, this much will anti-clockwise movement means it is 40 into 40, it is 1600, see it's 40 into 40, it will give 1600, so this much anti-clockwise movement. Similarly, find clockwise movement, same way you can find the clockwise movement, see clockwise movement also 20, see the distance, see the weight into distance, simple, 20 into how much distance, it is placed on 90, so 50 between 50 and 90, it means 90 minus 50, again you will get inside this 90 minus 50, so 40, so 20 into 40, 20 into 40, and then you will get 20 into 40, 800. So, if both are equal, what do you feel? Not equal. So, clockwise movement is not equal to anti-clockwise movement. So, no, see which side have more movement? Anti-clockwise. Question is, see, the question is asked, the meter rule is in equilibrium. If both the torque or movements are equal, then we can say that it's an equilibrium, but here both are not equal. So, what is your answer? No, it's not in equilibrium, first answer. Then on which direction, question also one more time is there, if not, see don't expect that always it's not in equilibrium, maybe first calculate, maybe it's possible that they are in equilibrium, so that's over, that question is over, but here they are not in equilibrium. So, if not, how will rule turn? On what direction rule will rotate? Normally, which side have more movement? Anti-clockwise. So, it will rotate on anti-clockwise direction. The rule will rotate on anti-clockwise. So, we just find the moment of force or torque on both sides. Then which one have more torque? On direction it will rotate. So the rule will rotate on this side, anti-clockwise direction. Next question. See, that question is not seen before. See, how can you rule brought in equilibrium by using additional weight of 40 grams? Just listen, I am solving that section. Okay. See, question is, see, how can the rule be brought in equilibrium? How can the rule be brought in equilibrium by using an additional weight of 40 GF? So we have placed a 40 GF weight to it. Then where should be placed? That should be placed to be in balance. So we can start. Okay. So anyway, since anti-clockwise side have more moment of force, so don't touch on that side. Which one have more torque? Don't touch, because we need to balance with the other side. We need to add everything on other side. So no need to change anything on that greater side. It means anti-clockwise side, no change. Okay. So anti-clockwise side, we are not changing anything. Same thing, 40 into 40. Don't touch anything on anti-clockwise side, which have higher moment of force. So we need to change the other side. Then only we can make it balance. So what about other side? Other side same way. We have 20 here. 20 into distance. Okay, that, see how much momentum we have, that doesn't change. 20 into this. Okay, this one. Okay, I am not writing separately. It's 20 into 40. Then we are add one more term. Okay, we are adding one more weight. So plus, we are adding that weight. Plus, how much weight we are added? 40 gram. 40 GF, but we don't know where it's placed. So that distance we are placing as X. So it means, see, it's not only for single weight. Whatever may be the number of weights you can add. See, whatever may be the weights placed on this side, just weight into distance plus weight into distance. Total, you will get total moment of force. Okay, weight, distance, like that. So just imagine 10 weights are on this side, means clockwise side. So first weight, distance, plus second weight, distance, plus third weight, distance. Like that, if you add all, you will get total clockwise movement. Similarly, you can do in anti-clockwise side also. Weight into distance is not only for one weight. Whatever may be the number of weights we have, they are together participating in that torque. So we need to add each and every one. Weight into distance, like that we need to add. Then you can find where you should place that weight. It means X you will get a distance. Okay. So at that position you need to place that 40 gram weight. Okay. At that position you will place that 40 gram weight. Okay. So okay, just to complete it. Okay, just to complete it. Then, so clear, students? Students, is it okay? No. Renu. Okay, see, when you solve this one, what is the value X you got? Just respond. Anybody? Not like that. On what point you should place? Okay, like that is asked. Okay. So when you solve this one, what's the answer you got? I think so many cancellations will occur. See, first of all, just take this one to this side. Then so many cancellation, and yeah, this time become minus. Keep place it there. In this term denominator. Okay, what answer is, when you solve this, what answer you got? Yeah, 20. Okay. So, okay, see, it means 20 centimeter from 15 that what is the balancing point? Okay, 20 centimeter from that balancing point. It means, what is the meaning? See, your answer is not completed. If you find X, okay, if you calculate it, you will find as X equal to 20 centimeter. 20 centimeter, yeah, correct. X equal to 20 centimeter. It means that 20 centimeter is not the balancing point. You can guess, see, from midpoint 20 centimeter. So it means the balancing point, the weight should be placed at 70 centimeter mark. Okay, from the midpoint. See, on what side means that you have to understand from that clockwise movement, 90 clockwise movement, you have to understand left side or right side. So from that, the distance from the midpoint you will get. The answer you will get, answer you are getting is from the distance from the midpoint you are getting. Okay, this side or this side, both are possible. See, here this question itself is given. We need to add mass here, then only it will balance. So that's why we write on this side. Okay, maybe possible that the mass should be added to this side, then add weight to this side, other side. Okay, see, I'm saying this again. You should, if you can solve this one, only if you have proper experience. Don't expect the same question will ask on board exam. See, collect previous question papers and solve one by one. If any difficult one, then I will solve. Like that, if you have the practice, then only you can attend the exam questions on board exam. Okay, so so the distance from 50 is given. Then you have to understand on what side should place. From the question or other values you are obtained, you have to calculate that. Okay. So is it okay? 11th question. Fine. What about 12th? I think that also. I think that also same question, right? 12th question. How many need to solve? Easy question, I feel. 12th question is easy. Just respond. How many need to solve? 12th question. Just respond, students. Question number 12. Just, I think it's very simple, I feel like that. Okay. So I'm not wasting time for the 12th question. What about 13th one? A physical balance has its arm of 60 centimeter and 40 centimeter. The weight is kept on the pan. Longer arm will be balanced to the weight 100 GF kept in other pan. Okay, so what about this question? How many need to solve this 13th question? Same equation only. Just respond. 13th question. Okay, so anyway, just to give the method, okay, into solving and just to give the method, okay, a few questions, a few students are respond as needed. So just to give the method, okay, just method only. Okay, I am just erasing the board. See, proper practice is needed, then only you can solve this one. This kind of question you need to practice again and again. Okay, you need to practice again and again, then only you can able to solve this kind of questions. Okay, anyway, get back. I think 13th one they are asking. A physical balance has arm of length 60 centimeter and 40 centimeter. Okay, a physical balance have arm. So physical balance means normal common balance. Okay, which you need to wait in stationary stores and all. Common balance they are using. So that's asking that type of that's thing. So yeah, a common balance. A physical balance have one arm 60 centimeter and other arm 40 centimeter. So one arm 60 centimeter and other arm 40 centimeter. Okay. Then yeah, what's the weight kept on the pan? On the longer arm will balance the object of weight 40 gram kept on other arm. So what weight should be placed on longer arm? So they specifically say on where they are placing. So 100 gram is placed. See that unknown mass is placed on here. longer arm, they specifically say where they are placing longer arm. So, the unknown mass is placed there and this side they are balanced with the 100 GF or 100 GF. So, that is all. From this diagram itself I think is clear. Simple. See both sides. We are taking this side clockwise movement. So, this side is clockwise or anyway supposed to be equal. So, 100 into 40 equal to this side is over. Another side W into 60. Simple. Just solve W. Okay. So, simple question only. Okay. Okay, so simple question only. I think you can able to complete it. Am I right, students? So, yeah, almost time's up. So, students, I think remaining question also I think you can able to try. Okay, including say 18th one is not needed, including 17. Okay, just try all this question. I think we don't have time to explain next question, right? Okay, what about the 14th one? Feel is easy or difficult? 14th question. Students, see in this case they separately asked to find, see 14th question, yeah 16th one I don't have time to complete. Okay, so I have one more class, that's 9:30. 16th one, see what about 14th question is easy, just respond. Okay, anyway, we can 14th onwards we can try on next class. So, any doubt regarding including 13th one, just to clear it now. Any doubt including 13th one? So, you have to know how to solve all these questions. Okay, 14th one sub question, which one I think, yeah, that I think I can solve next class. Okay, yeah, it's almost time. Okay, so any doubts, is it clear? 14th one I will solve, if you are in doubt I will solve next class. Okay, so it's almost time's up, so you can go offline. Okay, see you next class. Thank you.